Hello everyone. So today in this video we are going to solve a question of LeetCode, that is search a 2D matrix. This is 74th question on LeetCode and this comes under the medium category. Alright, so let's start with the problem statement. Write an efficient algorithm that search for a value target in an m into n integer matrix. This matrix has the following properties. First one is integer in every row are sorted from left to right. And second property is the first integer of every row is greater than the last integer of previous row. Alright, so basically there are two properties. Every row of a matrix is sorted and the last element of the previous row like 7 is less than the like the first element of the next row. So basically the whole matrix is sorted. So to approach this question, the brute force approach is to search the element linearly, or we can say we can do a linear search here while visiting all the elements from 0th index to last index. So the time complexity of linear search is around big O of n, and n in this case is m into n, that is number of rows into number of columns. So if the time complexity is big O of number of rows into number of columns, then it would take a lot of time and we need to write an efficient algorithm here. So the efficient way to solve this question is through binary search. So binary search is an algorithm that finds the element in a array in complexity around big O of log of n, and the condition in the binary search is that the array must be sorted. So we have given a sorted array, but it is a 2D array. So let's see how can we change this array into a 1D array, or we can consider this as a 1D array, and let's see how can we do this. So let's take a example. So let's say we have an array, a 2D array of m into n, and we need to check, like we need to convert this array into a 1D array. So let's say we have matrix of x and y, and we need to convert this into a 1D array. So what we can write is we can write something like this. Let's say we can write matrix of, or we can say we can write array of x into m plus y. X into m is basically the number of columns into the number of rows. So like there are n number of columns and we will be multiplying the number of rows into this, because this number of columns will represent the one set and the number of rows will represent the next multiple of, like how many similar rows can be there. So basically this will give us a 2D array. And how can we approach the question? So like if we need to find a element, particular element in this array, so we can call something like this, like x. Let's say we have a element, like we have an index on the 2D array. Let's say we have an index, let's say we have an index, this one, and we need to search this index in a 2D array as a 1D array. So what we will do, we will just divide it by number of columns, and we will take the modulus of number of columns. This will give us a particular element which will be represented as a 1D array in the 2D array. So let's take the first example and let's see how can we approach this. So in the first example we have 1357. Let me just copy it down here. So we have this example. In this example, so what we usually do in binary search, let's take, let me write target here. Target is 3, and let's take two variables. First one is l is equal to 0 and r is equal to m into n minus 1. This is the last index, or we can say the total number of elements minus 1 in the given 2D vector. Now we need to calculate the middle pointer. So middle pointer is basically the average of l and r. So here r is, let me write it down here, r is, we have 3 rows and 4 columns. So 4 into 3 is 12, minus 1 is 11. So we have 11, r equal to 11. So middle for this is 11 divided by 2 is 5. So mid is 5. Now let's take row will be equal to, like we have seen in the previous example, that we will be taking row in such a way that middle of like the middle is divided by number of columns, and columns will be middle of modulus of column. So let's calculate for this mid or so mid divided by column is, we have mid equal to 5 and number of columns are 4. So 5 divided by 4 is 1 and 5 modulus of 4 is 1. So let's check at 1 comma 1. 1 comma 1 is 11 here. So 11 is greater than target. So let's change right to m minus 1. M is like middle point is for m. Oh, 5. So 5 minus 1 is 4. Let's update r to 4. Now let's calculate middle point for this. 0 plus 4 divided by 2 is 2. Let's calculate 2 divided by column, that is 0, and 2 modulus of column. So 2 modulus of 4 is 2. So let's check at 0 comma 2. 0 comma 2 is 5. 5 is greater than 3. Let's update r to m minus 1. M minus 1 is 1. Now update middle point is 0 as 1 divided by 2 is 0. Now middle one is 0, so it will be 0. Mid all 0 is modulus of anything is also 0. Let's update it to 0. Let's check at 0 comma 0. At 0 comma 0 we have 1. 1 is less than 3. Let's update L to m plus 1. M plus 1 is 1. Now the average of 1 and 1 is also 1. Let's check at 1 divided by column, that is 0, and 1 modulus of column. Column is 4 and 1, so modulus will be 1 here. Let's check at 0 comma 1. So at 0 comma 1 we have 3. We have got the target, so we will be returning true in this case. I think the approach is clear to you. Let's quickly code it up. So let's first take two integer values which will be storing the number of rows. So number of rows will be matrix dot size, and number of columns will be matrix of 0 dot size. Now let's take two variables, int l is equal to 0 and r is equal to rows into columns minus 1. Alright, now let's run a while loop until l is less than r, and let's take int middle point is equal to l plus r. It is the average of both of them, so l plus r is quit. Then yeah, this is a quick way to calculate because most of competitive programmer use this way. So yeah, let's check if matrix of middle modulus of column and middle divided modulus of column, this should be divided by column and it should be equal to target. Then let's return true, else if matrix of middle divided by column and mid modulus of column is less than target, then we will be updating L to mid plus 1 and else R is equal to mid minus 1. I hope it should work fine. Let's just return false from here, as if the element is not present in here, and L will become greater than R. So this while loop will exit, and it means the element is not present in the given 2D vector, so we will return false in this case. So let's quickly run it. We have done a spelling mistake here. Yeah, it's working fine. Let's just submit it. Alright, so let's calculate the time and space complexity. So time complexity of this solution is big O of log of n into m, and space complexity of this solution is big O of 1, since we are using constant spaces here. and time complexity is because of log of n into m, because we are using a binary search here. So I hope the approach is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.